So hello everyone, my name is Sukhada Sanan Kulkarni. Today I am here to present in front of you the topic in the operating system for we use for memory management and it is very important, that is swapping. So let's see what mean by swapping. Let's see first introduction. What is swapping? So swapping is a memory management technique used by the operating system to temporarily move an entire process or part of a process from main memory RAM to secondary storage like a hard disk or SSD and back again. Its primary purpose is to allow to system the run more processes than the physical memory can hold, thereby increasing the degree of multiprogramming and ensuring efficient CPU utilization. So what mean by swapping? So in the swapping, what happened? We use the initial memory, that means the RAM memory in our laptop. So if the laptop memory get full, so and we want to utilize more memory, so we what we can do, so we shift our storage or some files to temporary to permanent memory storage, that is like PPT, CD, DVD. We store in that memory type, so we get some space for our new file generation. That mean is swapping for memory management. Next, purpose of swapping. What is the purpose of swapping? So first is increase multiprogramming. It allow a greater number of processes to reside in memory, or at least have their state stored than physical RAM would ordinarily permitted, thus keeping its CPU busy. So increase the multiprogramming. For increasing the multiprogramming, we want to do multitask at a time. So we need some space, more space. If we full our space, so increase multiprogramming, it increase the multiprogramming speed. Second is support larger process or application. Program that require more memory than a physical available in RAM can still run efficiently. We require more memory, more space for our larger process. So we need a physical device to shift our data to that. Then third is prevent system crashes by overloading inactive data. The OS can uh, prevent out of memory error and maintain system stability during heavy memory uses. When we use heavy memory, then it prevent that system crashes. If we use over memory, then that chances of getting system crash is more than execution of that process, so it prevent the chances of getting crash. So fourth one is efficient resource utilization. It ensure that the most active and critical process have access to sufficient RAM for optimal performance. It look that it have sufficient memory for the optimization of the problem. All we have this type of storage in our bag. So this is main pen drive, so we use this to keep our memory into that storage. If we have our we full our memory, then what we do, we want to adjust or create some more space for that. So that for that reason we need swap space, preventing out of memory error. It provides a safety net when RAM is existed, ensuring system stability and preventing application crashes, supporting multitasking and larger application. It allows the system to run more applications simultaneously, than the physical RAM can hold, and enable memory intensive programming to work with the larger dataset, enabling hibernation for system that uses the hibernation feature. Suspended to disk, it entirely content of the RAM is saved to that swap space, requiring the successful large swap area functionally correct. So next one is step in swapping. There are mainly two steps in the swapping: swap out and swap in. What it mean? What it does mean? Swap out means when the main memory RAM is full and system needs space for the new or higher priority processes. The operating system select a process that currently inactive or have low priority and move it to designated area. And the secondary space, it's called swap space. So if we require some space and we have the lack of space, so what we do, we swap outs means swap out the memory into the another storage. That means this like pen drive or CD or DVD etc. Yeah, for swapping at a later time, when the execution is swapped or out process need the resume, the operating system retrieves the from the swap space and load it back into the memory. If for example, if I need some space, more space, and I remove or I withdraw some files to that secondary memory, then again I, for the some reason I need that file again, so what I will do, I will reverse that file into my PC again. Next one is swapping process diagram. So let's see how the swapping memory works. So in this, as you can see, this is the operating system. In the operating system, there are main memory. In the main memory, we store our data. So from this secondary memory, the memory is swap out. This memory is accessed. So we swap out this memory into main memory, and from the main memory we swap in the memory P2 from the to the secondary memory. This is the process diagram of swapping. uh, Now advantage of swapping. So increased degree of multiprogramming. Swapping enable more processes to be loaded into memory than the physical RAM can hold at one time by moving inactive processes to disk. That ensure the CPU is kept busy and improving overall system through output. Efficiency memory utilization. It allows the operating system to make better use of the limited main memory by freeing up RAM from inactive or lower priority processes for those that we active the require immediate CPU time. Support for larger processes. Swapping permits that execution of processes or application that are larger than the physical memory available by loading only the necessary part into RAM as needed. System stability and prevent of crashes by providing a safety net when physical RAM is existed. Swapping prevents the system from running out of memory and crashing, thus ensuring greater system stability. Improve response time. Processes do not have to wait a long time to be exhausted because memory space can be made available for them via swapping, reducing the average waiting time. Flexibility in memory allocation. Swapping provides flexibility in dynamic allocating in reallocating memory based on the changing demand of running application. Next is disadvantage of swapping. Performance degradation. The most notable disadvantage in that accessing data from secondary storage, hard disk or SSD, it vastly slower than accessing it from physical RAM. This performance gap causes significant delay whenever the swap in or swap out operation occur. Trashing. If the system is under extreme memory pressure and spend more time swapping pages in and out of memory than executing actual instruction, a pathology condition called trashing occur. Then this can render the system very slow, unresponsive, or even cause it crash. increase this input output activity. Frequent swapping lead to increased read and write operation on the disk drive. This can lead to input output bottleneck, and in the case of SSD increases where the potential shorten the drive lifespan due to limited number of write cycle. So example, what example of the uh, swapping? So in our daily uses, memory management system, in an operating system the computer swap data entire inactive program from the fast main memory RAM to slower secondary storage hard drive. When RAM is full, this free up RAM for active programming and in the critical function for multitasking. Financial swap, to cooperate entity might enter into a financial swap contract to exchange cash flow from a different financial instrument, such as an interest rate swap uh, or a currency swap. To manage risk,